Hello class, today we're doing chapter 6, Algebra, Equations, and Inequalities. This will be chapter 6.4, the linear equalities in one variable. Our objectives today are to graph subsets of real numbers on a number line, solve linear inequalities, and solve applied problems using our linear inequalities. Let's look at it. Start with the definition of linear inequalities. A linear inequality, ax plus b is less than or equal to c, where the inequality symbol can be less than, greater than, less than or equal to, or greater than or equal to. The little line under the greater than or less than sign is the equal to part. If it doesn't have that, it's not equal to. Solving an inequality is the process of finding the set of numbers that makes an inequality a true statement. A solution set is the set of all numbers that satisfy the inequality. So, let's look at graphing subsets on a real number line. Alright, so we have our set builder notation on the left and then our graph on the right. Now remember with set builder notation, we have x such that x. So x here such that x, and then our statement is less than a. So x is a real number less than a in this circumstance here. I've got my graph. On my graph I have an a and a b. I locate my a. It's not equal to, it does not have the equal to line here. So I put an open circle on my a, on my line right here, and then I draw a line to the left because x is less than a. Easy enough. Now here I have x such that x is less than or equal to a. Very similar. I go to a on my graph here, I put a closed circle or closed dot on my a here, and then I draw my line to the left hand side. The equal to part right here indicates that I do that closed circle because it actually, the answer in that case actually can be a, so I need to include it. Here I have x such that x is greater than b. So x is a real number greater than b. I locate b on my number line. It is right here. And I do an open circle on it because it's not equal to it. And then I draw my arrow out to the right hand side because x is bigger than that b. It's greater than it. Next one I have x is greater than or equal to. Oh, notice the equal to sign attached to the bottom there. Means I need to do the closed circle on the b. And then x is greater than, so I draw my arrow to the right hand side. Next I have x such that a is less than x is less than b. So now x is bounded by these two numbers. It's not equal to either of them because it doesn't have the equal to sign on either of them. But it's greater than a and less than b. So I put an open circle on a, I put an open circle on b, and I connect the two open circles or the two open points there. And the x lives between a and b on that blue line right there. Might be a green line. I'm slightly colorblind. I really couldn't tell you. All right, we have a is less than or equal to x is less than or equal to b. Okay. Because x is equal to a and x is equal to b, I have solid dots on those particular points here, and then I connect those 2 points with this line in between, and x could be a, x could be b, or x could be anything in between. Then we can mix it up a little bit. We have a is less than or equal to x is less than b, so it's equal to a, so I put a solid circle on the a, I put an open circle on the b because it's not equal to b, so it could be a on up to b, but not equal to b. So I connect it that way. And then I have a is less than b is less than or equal to, a is less than or equal to x is less than or equal to b. Got a little bit of a hurry there. So I'll put my open circle on my a, my closed circle on my b, because the b is where it's equal to now. So x could be the b, could be anything on down to a, but not equal to a. So I make that line. So let's actually do some graphs in these sets here. So x such that x is less than 3. I need to locate 3 on my number line. Here it is right there. And I need to put an open circle on it because it's not equal to 3. But it is less than 3. So now I need to draw my line on this graph going to the left-hand side. And boom, there it is, right there in blue. Now, b says x is such that x is greater than or equal to negative 1. Now, it's equal to negative 1, so I'm going to come over here to negative 1. Here it is. And I'm going to put a closed circle on it. And it's greater than, so I need to draw my arrow to the right. There she goes. Now in C, x is bounded. Negative 1 is less than x is less than or equal to 3. So I need to go to negative 1. Negative 1 is less than x. So I need an open circle on this negative 1. And on this 3, because it has the equal to on it, I need a closed circle. And then I can combine those two and draw the line between in order to have this inequality that negative 1 is less than x is less than or equal to 3. So, solving linear equalities in one variable. The procedure for solving linear inequalities is the same as the procedure for solving linear equations. And we have solved plenty of linear equations by this point. So hopefully you are familiar and good to go with plenty of practice on that. We're going to take that practice and transcribe it into this linear inequality solving. There's only one exception. There's always one exception, right? When multiplying or dividing both sides of the inequality by a negative number, we're going to reverse the direction of the inequality symbol, changing the sense of the inequality. So the only thing we need to really worry about here that's different than what we're going to be doing in the past is when multiplying or dividing both sides of the inequality by a negative number, we're going to switch that inequality. Which means if it was less than, we're going to switch it to greater than. If it was greater than or equal to, we're going to switch it to less than or equal to. So let's look at an example. Let's do an example. Let's put some numbers on the page and get it done. So we're going to solve and graph the solution set 6x minus 12 is greater than 8x plus 2. We need to get x by itself. And we're going to do it on the left-hand side. I'm going to move it to the left. So first thing I'm going to go do is I'm going to subtract 8x on both sides to try to get this x on the left-hand side of this inequality. Now, when I do that, obviously these 8x's are going to cancel out on this right-hand side where I've subtracted it off here. And 6x minus 8x simplifies down to minus 2x. The negative 12 and the 2, just bringing those down, not doing anything with those quite yet. We'll do something with them in the next step. I want to get this x by itself now. So I'm going to add this 12 over. And what I'm going to see is that'll cancel it out off of this left-hand side. And 2 plus 12 is now 14. That simplifies down here. And I have negative 2x is greater than 14. Now the problem here is going to come in the next step. Everything now is pretty much the same thing we would have done with an equality until we get here. To get x by itself, I need to divide both sides by negative 2, which is what I do right here. Now, when I do that division by negative 2, I need to switch this inequality. So this greater than turns into a less than. And I see now that this cancels out. I'm left with x is now less than negative 7. Because I divided by a negative, if you divide or multiply by a negative, you have got to switch the sign. And now I have my solution here that x is less than negative 7. We could also write that in interval notation. If you're going back to Math 108 or you plan to take Math 108 in the future, you do need to know your interval notation. Interval notation here would be negative infinity to negative 7 with the parentheses because it's not equal to. But we also need to graph. The solution set is x such that x is less than negative 7. And the graph is we put a circle on negative 7, an open circle on negative 7 here, and then we draw our line to the left because it's less than negative 7. Remember, don't color that circle in unless it's equal to. Here it's not equal to. It's strictly less than negative 7. If you wouldn't have switched that inequality, you would have gotten it completely in the wrong direction. That is the only exception you need to worry about. Now, we just solved a two-part inequality, just like we've solved two-part equalities in the past. But we can have more than two parts to an inequality. We can have a three-part inequality because we've seen those. We've seen negative 3 is less than x is less than 5. So we've seen inequalities on both sides of the x. So how would we handle that in an equation format? Let's try one. It says solve and graph the solution set negative 3 is less than 2x plus 1 is less than or equal to 3. We have three pieces here. First piece is negative 3. Second piece is 2x plus 1. Third piece is 3. We have a three-piece or three-part inequality. Works the same way as the two-part inequalities or the two-part equalities. You still keep the exception. If you divide by a negative, you got to switch all the signs. But what you do to one piece, now you, instead of doing it to two pieces, you have to do it to all three, because you have three pieces instead of two. Isn't that simple? So what you do to one piece, do it to all of them. Be equal. Be just as fair to one piece as you are to the other. So here, first step, I've got my equation here. I want to get my x by itself here in the middle. I'm going to subtract 1 from both sides. Say both sides. Technically all three pieces, right? So negative 3 minus 1 is negative 4. 2x plus 1 minus 1. That's going to cancel itself out, just like it cancels here. 3 minus 1. You don't have to write as many steps if you don't need them. But if you're not getting the answer correct, you maybe should write all the steps. Now 3 minus 1 is 2. That's where that 2 comes from. Now I have it now simplified down to negative 4 is less than 2x is less than or equal to 2. Now I need to get x by itself. I'm going to divide by 2. But I have to do it on all three pieces. So here I have negative 4 divided by 2 simplifies down to negative 2. 2 divided by 2, 2's cancel itself out, simplifies down to x. 2 divided by 2 equals 1. And that is where that 1 comes from there. So our solution here is negative 2 is less than x is less than or equal to 1. I'm going to go ahead and show you interval notation in hopes that you want to progress your math career into 108. And, you know, just a little hint into that would really help you going forward. So if we wrote it in interval notation, it would look like negative 2, comma 1 with a bracket on it because it's equal to. But we also need to graph it on our number line. So I'm going to go to negative 2, do the open circle here, open circle on negative 2 because it's not equal to, close circle on 1 because it is equal to, and connect my dots here. So it lives between negative 2 and 1. And we have it graphed. We have it graphed. That concludes our chapter 6.4 lecture. Go in. You'll have plenty of homework problems to try and brush it up on. Make sure you take it step by step. Don't forget the exception of when you divide and multiply by a negative, you need to switch that sign. If you have any questions, because some of these can be a little tricky, if you can't figure it out, don't hesitate to send me an email. I'll get back to you as quick as I can, and we will get it figured out on where you're going wrong, right? So I hope to see you next time for chapter 6.5. I'm looking forward to it. In the meantime, like I said, any questions, comments, criticisms, don't hesitate to reach out to me by email so I can help you out. Y'all have a good afternoon.